Hello and welcome everyone to the Past Marathon Architect. Exciting. We're excited to have you join us today for Robert Hart's session. His session is on adding data quality to a Kimball data warehouse. This past marathon features back-to-back live webinars. I'm sure some of you have actually been part of them already, delivered by expert speakers from within the past community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available so that way you can actually get it to it whenever you're liking. My name is Glenda Gable, and I'm actually have been a DBA for quite a number of years. We won't say how many. And I'm also a moderator at the DBA Fundamentals Virtual Chapter. So make sure you're checking out all the virtual chapters within the past community. I have a few introductory slides before I hand the reins over to Robert. If you require technical assistance, please use the question pane located on the right-hand side of your screen, and myself or someone will help you and assist you right away. The question pane is also where you can ask many questions to the speaker himself. We will be waiting and keeping the question and answers portion of the session at the very end, but if I can answer anything in the middle, I will try to. You are able to zoom in on the presentation content by using the zoom button, which is located at the top of the presentation window. Please note that there will be a short evaluation at the end of the session. This will actually pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete it if you have a moment. We'll also have a couple of polls throughout the session, so it'll be awesome to get your opinion for the speaker in between that. Thank you to our presenting sponsors, Influx Data. Without this support, these type of events can't happen. So this is amazing for them to step up and be a sponsor. If you'd like to learn more about them and their solutions, please visit the sponsors page in the Past Marathon website. Thank you again to Influx. Past Summit is coming up. It's right around the corner. It'll take place on November 6th through the 9th in Seattle, Washington. If you haven't registered yet, you can use the code MARATHON, as it says on the screen there, to save $100. Hope to see you at this year's summit. Exciting, it comes every year, it's amazing. This session is presented by Robert Hart. Robert is a very highly qualified data warehouse professional with over 15 years experience in dimensional modeling and 20 years as a database administrator. He's worked on multiple roles, including project manager, team lead, data warehouse architect, as well as ETL developer. He's also built data warehouse solutions on DB2, Oracle, and SQL Server. His contact information will also be posted at the end as well. And without further ado, here is Robert with adding data quality to a data Kimball warehouse. Take it away.
Hello, and thanks everybody for attending this session. So to go over things from just the start of things and an agenda, we're going to be looking at 5 different components. I'm going to go over what is data quality, the foundational elements you need to build data quality in your data warehouse. Now, these first 2 points I'm going to go through relatively quickly. They're not technical. I've primarily included them just for knowledge purposes. Then we get into the actual technical build and implementing this solution into your data warehouse. That's where we start the design and implementation. We'll look at the reporting feedback to the business. Primarily, this is just creating your dimensional structures. And then also some results from a case study of us implementing this data warehouse data quality in here at Island Health. Now, this first question you have to ask is, what is data quality? Now, the definition here is compiled from various sources and articles I've read. I've got a reference down at the bottom to 3 data quality books if you're into some light reading. They're actually very good. I'd highly recommend them. So data quality is primarily an assessment of your data. You have to look at, is the data viable or fit for the purpose you're looking for? Is it timely? Is it accurate? Is it complete? Is it consistent? Is it comparable? You look at all the aspects of data and how you're actually using them.
Before
So,
you move on, are you ready for the first poll?
um, yes, let's do the first poll.
Awesome. If you guys can take a moment, are you familiar with data warehouses and the Kimball methodology? Yes or no? Give about 15 more seconds or so, and then we'll tally the answers. All right, it looks like a very overwhelming yes, actually. You have about 89% yes and 11% no.
Okay, so most of us are data warehouse people then. Um, I guess from the perspective of data quality, it comes down to one thing. Is the data fit for your purpose? Now, from the foundational elements, from my own perspective, when we started building data quality, it was because of mandated reporting. I have to provide data and I have to report to various levels of government. So because of this, Island Health, which is the health authority that I work for, we developed a data quality management framework and we built it into our data warehouse. The number one, probably biggest, and I cannot understate this thing you need as one part of your foundational element is organizational commitment. If you don't have a commitment from an executive level and staff level, don't even start. You'll essentially never really accomplish the goals of trying to improve your data quality. Executive have to support it, staff have to be willing to work on it, and you have to build on a culture of data quality. If you cannot get these pieces in place, really don't start because you're just going to make your own life miserable and you're not going to accomplish anything. Metadata is another thing. So metadata, data about data, domain knowledge, subject matter materials. You need to have some metadata to actually know what you're applying your data quality to. This can start simply. In my own case, we started building our metadata repository just based on data dictionary. And then we expanded it with business information, and then we expanded it further and we started putting in other definitions. And we now have a full-blown, pretty large metadata repository. But it started simple. It started about 5 years ago. And when we first did our data quality engine, all we had was our data dictionary. After that, your business has to do something in terms of master data management. For most businesses, this isn't much of a challenge. It is in my area because we have such diverse data. In terms of how we do for master data management, probably my organization is about a C. Uh, there are some parts where we do extremely well. Diagnosis information, surgical procedures, things like this, we'd probably be straight A. But in terms of some of our other data, like our doctors, maybe we're a D for some of them. So we have a very well balanced approach though. For a lot of our metadata or for a lot of our master data in terms of the corporate systems, they actually have to implement new code values in a test environment before they migrate it up. So in that aspect, we're actually quite good. But you do need at least some basic product tables or something. Uh, and then the last element for data profile for foundational elements is some data profiling. This is actually more of an exercise. When you're starting to work towards data quality, the first thing you're going to have to do is just find out, what does my data really look like? This is where the surprises start to happen. I cannot basically undervalue this step because you'll actually start seeing what's actually in the data. There are some very good commercial products available. If you use SQL Server Integration Server, there is a data profiling capabilities within SSIS. I've used it within SSIS. I've gone and looked at my data directly with SQL. You can do things like find out that from people that say this field is mandatory and you find 200,000 null values. Little things like that tend to pop up. So you do have to go through the exercise of actually looking and seeing what's there. So if metadata and master data define what your data is supposed to be, your data profiling exercise will show you what it actually is. So now I'm going to get into our design and implementation. So at this point, I think I'm going to, from this point on, if there are any questions, um, I'm going to let the moderator actually interrupt and provide the question to me. So we'll try and answer them during the presentation. So the requirements I had when I came in to develop the data quality framework within my data warehouse was I had to identify data quality errors in the data warehouse for any and all tables. Doesn't matter what fact table it is, doesn't matter what dimension it is, I had to provide them anywhere, and I had to provide a reporting solution for that as well. Lastly, besides that, they actually wanted to measure performance. How long is it taking us to fix these data quality errors? How many data quality errors do we have by area? We never did get to the point, but it's been something on our requirements to try and develop, is essentially a scoring for our metrics. So for our fact table, we actually want to be able to report that this is your metric. These are how many, for example, hospital encounters you've had, and this is the percentage of errors you have for that in that given time frame that you're working with. So out of everything, this is the secret. This one slide is the single slide for you to look at to actually get what we're doing here. If there's one slide you're going to pay attention to, this is it. The secret underlying factor of our entire data quality engine is we apply a unique identifier to our tables. And that is not a unique identifier like a primary key on a table. That's a unique identifier across all of our tables. So that data warehouse sequence ID, we populate it from a sequence inside our database. As the data is replicated in and goes through our staging areas, we assign a data warehouse sequence ID and it flows through into our ODS layer, which has all our data. It flows all the way down to our star schemas as well. We have every record identified uniquely. Now, as I said, I actually do have that data warehouse sequence ID flow from my tables, my source tables, all the way to my targets. So my source patient table does come into my dimension table, and that data warehouse sequence ID is the same value. But that's the only situation where I actually have the data warehouse sequence ID value the same in two different tables. So everything is uniquely identified. It's uniquely identified for my dimensions and my fact tables. They all have a unique identifier. Now, in terms of my data quality engine, our data quality system is essentially based on a single table of data quality rules. Our data quality rules are basically SQL statements. All you have to do for our data quality system in terms of developing the rules is select the data warehouse sequence ID from whatever table you want that is in violation of the rule. Each data quality rule identifies the record that is at error. Our data quality rules are very simple, straightforward to develop. They're captured in this table. We have name, notes, status information, and we actually link from here into our metadata repository. I didn't really expand on that part very well or very much. It's just my last field, I just put it as an information object identifier. That would foreign key into my metadata repository. But for the most part, the data quality rules stand by themselves. My rules vary in complexity. They're actually go from being quite simple, does the patient actually have their birth date populated? Does that encounter, was the admit date greater than the discharge date? Like, you can't be admitted after you're discharged. Doesn't make sense. For home care hours, here's another example. Are they entering a negative value for home care hours? Very simple rules here. Now, my rules vary in complexity. For some of them, they're quite simple like this. Is it a null, not null on a column? Is it one column greater than or less than another column? But they go from here all the way up to data quality rules that take about 5 minutes to run and go across multiple subject areas. Is the patient receiving a service when they have not had that assessment and the score on this assessment was X? You know, that's the degree to which we have to take care of things. So they vary in complexity, but in every single data warehouse rule, all we have to do is identify that one record with the data warehouse sequence ID. Our data warehouse rules are run through a cursor. So the data quality rules execute and we capture the results. Now, I've got another poll here before I go farther. Um, so if I think that I'd like to know just how many of you are familiar with SQL merge? Give a minute or give a few seconds for people to respond.
No problem. About 10 more seconds or so. All right, you're looking at about 86% yes and 14% no.
Okay, so as I said, our data quality rules are executed. We capture the results in a rule violation table that has the data warehouse sequence ID and the data quality rule ID. That cursor and the stored procedure that actually fires this is very simple. Essentially, it's a cursor that reads the data quality rules table. We take the SQL code, we put it into a variable SQL code. The data quality rule ID is populated as well. And we run a merge statement that merges the select statement into our validation error target table. It's a straightforward join on the source data warehouse sequence ID is equal to the target data warehouse sequence ID. Source data quality rule is equal to target, and the date resolved is null. One of the fields you may have noticed on my table was a data resolved date. So I've got a date it was identified and I got a date resolved date. Guess how many times people will actually introduce the same error again and again and again. Like it or not, this actually happens. I've had one record go into an error state for the same thing 12 times. I don't know why this happens. They have to go fix it after that, but these kind of things happen. So I want to keep a history of it, so I actually populate the date resolved, and in that case, it's no longer a valid error, or it's a fixed record. And now I can actually figure out how long it was in error state. So this is the merge statement, which takes our select and joins it to the target table. Merges are pretty straightforward. From the merge, I then do one of two things. When it's not matched by source, which essentially was the source query, that means the rule has, or the record has been fixed. So all I have to do is just put my date resolved equal to today. I'm done. If it's not matched by target, then essentially I have a new data quality error. And I insert into my validation error table the data warehouse sequence ID, the date I evented it, and the data quality rule. And with that slide, for the most part, we're done. We've captured all our data quality errors. Now, the structure as I showed you, and the little trick of putting your data warehouse sequence ID on all of your tables, and the stored procedure and the cursor to actually run your data quality rules, you could implement this in your database in a day. Writing the data quality rules, you're going to spend man years on that. I've literally had for one project, which was our surgical services, essentially creating a surgical services subject area and submitting data to the province, which has to be done on a daily basis after midnight with that day's data. That took us about a man year. We've got over 100 data quality rules. They have to look at the patient's diagnosis, when the diagnosis occurred. It has to look at some of their medical history records. It has to look at the surgical booking, the request, the schedule information, and the actual surgical complete information. Was there a
When
question?
you have a second, you do have a question. Yes. So how does the data warehouse sequence ID get applied? Is it an identity in each table, or is there a separate table from which the values are drawn? Do fact tables have different data warehouse sequence IDs than DIM tables, or are they related with other foreign keys?
All the data warehouse sequence IDs come from the same sequence. I created a sequence in, it's similar to an Oracle sequence. I created a sequence in our replication database where we actually pull the data in. And for most of the records, they're populated when on insert. I essentially created a default value on our data warehouse sequence ID to be select the data warehouse sequence ID next value on a new record being inserted. So it was actually, it's pretty straightforward and simple to do. In some situations, I have data that comes in as a flat table or like a flat file structure, and it's the entire table data set every single time. In that situation, I have to then look at, okay, what is the key value that's coming in there and compare with the existing copy I have to just copy the changes. In which case I only would put a data warehouse sequence ID on it for the new record and leave existing records with their existing value. The data warehouse sequence IDs that flow through the fact table corresponds to what would be my transaction record table. The data warehouse sequence ID on the target dimension corresponds with my dimension source table. The base table for that, because my dimensions tend to be somewhat complicated. There may be 15 or 20 different tables that contribute to it. But the base record, there has to be a base record somewhere. Now, in my case, I do have fact records where there is no source transaction table. You have to understand that in healthcare, our data can be highly complex. And a good example of that is authorized hours or calculated hours. When we assess a patient, we look at their healthcare. There's about 500 different attributes on a comprehensive patient assessment in certain situations. And from that patient assessment, they calculate this is the number of hours this person needs for support. And that's a monthly value. But in my fact table, we want to break that down to have annual reporting. So we essentially put in a weekly record for every single assessment on that patient. So if I have an assessment on January 1st, and then I have another one 6 months later, on the January 1st assessment, they'll be assessed at, say, they need 120 hours of care a month. We'll put in, 30 hours a week. And then on the next assessment that happens 6 months later, say it says, oh, they need 240 hours now. So then I'll put records in at 60 hours a week. But there's no real transaction record saying this is the authorized hours or this is the estimated hours. So those sequence IDs are generated when I put them into the fact table. All right, back to the slide. So as I said, at this point, we've captured all the necessary information to identify the error. We've got the data quality error. You got the data warehouse sequence ID for the record at issue. And the data warehouse sequence ID is independent of tables. It's unique in every single table. It goes across all our tables. I've got the date the data quality issue was identified. I've got the date the data quality issue was resolved. So from here, all I have to do is create my reporting structures. So I created 3 structures for my reporting purposes. I've got a data quality star schema, which essentially is a measure of our data quality across all our subject areas. I create a Kimball bridge structure to relate our data quality errors to our fact tables. And I create a simple bridge table cross-reference, if you want to call it, between our data quality errors and our dimensions. Now, as another question for everybody, is everybody familiar with Kimball bridge structures? And I'll give a few seconds to respond.
About 10 more seconds or so.
Sure.
All right, so you're looking at semi-even. So you have a 44% yes and
Mhm.
56% no.
Okay. Um, this slide is essentially a typical Kimball bridge structure when you're trying to resolve many-to-many relationship. Um, Kimball teaches this in his, or sorry, Kimball used to teach this in his advanced or dimensional modeling course. I took my dimensional modeling courses from the Kimball group directly. Um, what the situation where he basically developed this structure, and I'll actually iterate what he came through. He was doing a star schema or developing a dimensional model for new car sales. And in a new car sale, you have all these options. So you have like 60 different options on a new car. Well, that's a fairly small number of options, but the combination of options you had for every single car sale was millions, millions and millions and millions, because almost every car had a distinct set of options. So Kimball developed this structure for essentially optimizing the performance. Now, the way it actually works is you're not doing a direct cross-reference between your fact table and your data quality rules. What you actually do is you create a group table, which is a grouping of the errors that you have. So for one of my fact records, it may violate data quality error 1. Another one may violate data quality error 2. And since I have about 600 data quality errors, so you could go all the way up to 600. And then you've got combinations, fact record 12 violated data quality rules 1, 2, and 7. My data quality group table has a record for 1, 2, and 7. It has a record for 1 by itself. It has a record for 2 by itself. And then you just create the bridge structure in the middle, that transitory table, to be between the combination of records and your actual data quality rules. When you join to a fact table, the key value that will be in the fact table would be the data quality group dim key. So that group table that you see here is actually more of a helper table. You can skip it when you're doing reporting because the value is in the data quality group bridge. In my own situation, as I said, I've got about 600 data quality rules right now. Some of them are for dimensions, some of them are for facts. But my data quality group table, the unique combinations of data quality rule violations is 2,700. So it's a much, much reduced number of records. Now, that doesn't always work in all situations. Sometimes it'll reduce the number of records you have enormously, which it does in this situation. Sometimes the bridge structure is not going to help you out that much. In the situation I'm in, where I have multiple data quality rules applied to a fact record, I significantly reduce my errors. Um, the bridge structure is actually very easy to populate. It's essentially just one simple select statement. Now in my select statement, all I'm doing is selecting the data warehouse sequence ID. I wrote a little C# function inside our database, and I wrote this about 2005. I think, yeah, it was on SQL 2005 when we first developed it, so it was quite a few years ago. And what it does, that sort concatenate, is it takes your value, turns it into a string, adds it to an array, that concatenates the values together to give me essentially just the combination of data quality rule violations. It's an aggregate function. It runs really fast. I think the first time I tried to actually do it, I just tried to do the old, let's use a cursor and then sort through things. And stuff was taking like 15 minutes to run. When we did this, essentially my whole process for populating my um, bridge table structure and for this and a number of other areas, It takes me less than 5 minutes to process all my data quality rules up to this target dimensional structure. The rules themselves, when I'm executing the rules in the cursor, um, that takes hours. I've got data quality rules that run in seconds. I've got other ones that take minutes, and I'm spending, you know, almost, I think for one area it's about an hour. For another area it's an hour and a half. They're each run independently as part of the ETL process, but populating my structures is really fast. I don't really have any performance issues here at all. Um, so then for me to populate my actual dimensional structure, all I have to do is just select the distinct data quality rule group string from the table I previously created, populate my dimension. The data quality rule group dim key is just an identity column, and that gives me my group structure. The data quality rules, it's a straightforward copy or ETL process to put that into my dimension. And the last table I have to populate is my bridge table in the middle. And the bridge table, you just essentially have to look at the distinct combinations of rule violations to the combinations in a simple, straightforward query. This is essentially the query I use to populate it. It doesn't have the dimensional keys in here. Just to make it a little bit more legible, I skip the dimensional keys at this point. But what I do is I look at that one group table that we had, that I first generated, which was the combination of errors. I looked at that for the minimum data warehouse sequence ID. So I get essentially just the distinct combinations. And then I join that to the actual data quality rule violations on that data warehouse sequence ID. So now I have the individual violation records. So I know what data quality rule it was. And I've got my group string. And that essentially finishes off that entire group structure. So that group structure, think of it as essentially a conformed error structure. It can be now tied to every single fact table I have. I don't have to do anything else. I've created a data quality structure. It's a conformed dimensional structure, and it's used everywhere. Now, reporting feedback. The other one I have to create is essentially for when I have dimensions. As I said, I have to also identify data quality errors in my dimension tables. That one's not as complex as the bridge structure. Essentially, I have to create just a straight cross-reference between my dimensions and my data quality rules. It's pretty straightforward as well. So any dimension, it doesn't matter what dimension I'm dealing with. It could be the patient. Generally, it's the patient dimension. It could be the provider. Providers are essentially our doctors or other staff that are providing the service. Those are cross-referenced to the bridge structure to the data quality rules. And now I've got everything done. I've associated data quality rules to my fact tables. I've associated data quality rules to my patients. I do get a little bit trickier than this, and I've got another slide here where I'm showing the data quality rules for the dimensions, and I've automated the generation of a view. I've actually automated creating views to match my dimensions where I pivoted out the data quality rules. It's a simple, straightforward, and it makes it easier for the end users that they can then just join to the D-patient data quality without having to go through the bridge table. You could even generate it as part of a view, like have it joined into your dimension right off the bat. I did not do that in this case. I have done it in other cases. The patients, because of legislation in Canada, there's privacy legislation and people aren't allowed to see all the columns in the dimension. So we did it as a separate table in this case. But it's a straightforward query of the bridge table joined to the data quality rules, pivoting it out based on the field And my result is yes, you violated it, or no, you did not. I've got DQ error 1 and DQ error 2, just in a straight table. The naming of my data quality error columns, that's another thing that's always kind of interesting. One of my areas actually has numbered data quality errors where they essentially are doing it according to their own reporting requirements. So they've got numbers for everything. Other systems are doing it by the field names. There's quite a few different combinations, although it looks kind of bizarre when you see 768 as just the field value for a column name. And the last structure I actually have is a straightforward fact table of data quality. Most of my information is actually in my metadata table, which is the one on the bottom. That's not essentially what our data structure looks like for metadata information, but the complexity of our metadata would be an entirely different presentation. We have our data quality rule dimension here again. I've got the date that the record was identified as having an error. I've got the date it was corrected. My metric is essentially how long is it taking them to fix the error and record counts. The metadata information comes in when we're looking at what fact table has these errors, what business area has these errors, how long is it taking this business area to solve their data quality issues. And that's all captured in our metadata information area. So the metadata is actually much more complex than is shown here. And that pretty much finishes up this portion of it. Were there any questions?
No other questions so far.
No other questions so far. Okay, I'll quickly go through a case study of how we did of the results we have from this. One of the areas I have to do is I have mandatory reporting for the provision of home and community care. Home and community care represents care of people in their homes. This is largely people with the elderly and infirm, sometimes people with mental health issues, but it's essentially providing care in the home. All the health authorities are required to report their home and community care information to both the province and federal government. I have to report on service delivery being professional nursing visits, length of time. I also have to provide patient assessment records and information with this. I have to provide patient demographic information with this, and I have to provide patient income information with this. The patient income information is, we are a public healthcare system here in Canada, but these are subsidized services, they're not free. So from the patient income information, the government calculates this is what the person should be charged. And then we have to do the charging and recover those costs. The mandated reporting was, for me, required from the province, and I had to meet a 95% data quality pass rate in order to be accepted. I also have to have the volumes of information that report from that match our financial or management information system reporting. The federal reporting required similar data quality pass rates, but they required a lot more medical assessment information. They required the full assessments. And for them, it's required on a quarterly basis. The province requires it on fiscal periods, which are 28 days. The data errors we submit to the federal government, they come back with, these are your data quality errors, and we have 15 days to fix and resubmit. And financial incentives do apply to this. Essentially, perhaps incentive isn't the right word, penalties. Penalties do apply for this. So like in my situation where it was executive support for putting data quality in your data warehouse, when there's millions of dollars associated with it, yeah, I got really good support from our executive. The data flow for my patient care, home care data, there's 3 primary systems involved. Note I said primary, there's actually 5, but these are the primary ones. Patient registration takes place in our acute care system. Patient assessment and the service delivery is in a second system. And then home care service delivery, which is the home support for cleaning the home or meals kind of thing. That's in yet a third system. That third system is actually duplicated because there are two different service providers. And I have another system for adult day program, but this is complicated enough with just three. So I didn't display them all. The responsibility for the mandated reporting falls under my business area. I work in performance monitoring. Uh, what we did was, and this was the first project we did where we developed these data quality rules. We worked with home and community care to introduce data quality services into them and into their workflows. And we also provided them with some reporting solutions. They have over 100 data quality rules for that specific process. My total rules are over 500 right now. We're pushing 600. We've got two projects this year that are probably going to push it up probably closer to 800. The workflow that we essentially created with them, what they wanted was for their home care admin staff, like the administration clerical workers, to enter the patient demographics. That's the first step in it. And then on a weekly basis, they're required to run data quality error reporting checks. If they can correct the error, they correct the error themselves. If not, they have to forward the error to the professional staff being nurses or physiotherapists. Essentially, it's the professional care. Patients in the home care professionals, they're also the ones that have to enter the patient assessment information, and they have to enter their own professional service delivery. But they don't do the data error checking themselves. That's left to the clerical errors because the bulk of the errors can be fixed at the clerical level because most of them actually happen on the patient registration side. Now this is essentially just an example of my output. This is for the entire home care service hours over the past 5 years, which is about 17 million records. Against the service records, there are essentially, I think I've got about, they're numbered. So currently I've got 77 data quality checks against the service records, but not all the rules are being violated this time. And because I can relate this to my fact table, you actually have a breakdown of where my errors are happening. The biggest one I have is the service record has no client rate, which is service record 37. As I said, they number them. That error is because the professional person has not done their financial assessment. That was the income record I have to submit. Now the numbers here are much higher because they've essentially decided, they made a decision earlier on that they are not going to correct historical records. So they've only been doing their data corrections, I think only about 4 years. So a lot of this is historical. But here is what I have from the province in terms of my submission of mandatory reporting. So you've got the record counts of what I submitted for patient information, service information, and financial information. And then you've got the number of records I'm having rejected due to data quality errors. So for example, in February 25th, 2016, and that was actually fiscal 2016 is where that started. So that's actually last year. I had 13 records that were rejected because of a data quality issue. I'm getting like 0.1% is my error rates when I'm submitting data. Service information, surprisingly enough, most of the reason for my service records being rejected is there's no client record because the client record was rejected. And my financial information is record counts are there as well. So we are getting, right now, according to the province, our health authority, we have the best data quality of everybody in the province. Two other health authorities have now copied our data quality engine because they're also running on SQL Server. So their reporting is coming up to these kind of numbers as well. This is essentially the data quality errors coming back from the province. The second record where there's an error on the last update date, that's actually a warning. The other error is the big one there where it's the number 21 errors. It's because my birth date for the patient and their birth date for the patient are different. So who's correct? I've got the patient giving me their birth certificate saying this is my birth date, and the Ministry of Health is saying no, it's not. Those ones take a longest time to resolve, and that's the biggest error in terms of my records getting rejected, is I have a different birth date in my system from their system. The last one is essentially the client doesn't exist in the database because it has no service records. That's usually because the service records are being rejected for a different reason. But that number count of 21, that's my biggest issue. The record count of 275 is because we used to submit with the date being, this is the current date that I processed this record, but the ministry decided, no, we want when you change your record. So they changed the requirements for that field. So that record that says error is actually just a warning from the system because they still have the original date I sent them. And that is the end of our presentation. Are there any
Awesome.
questions?
Yes, so you do have two comments that you will get afterwards. I won't read those necessarily, but one question you had was, did I miss an example of the way data quality is caught? If it's part of the slide that you already have given, he'll go back and review, but if not, he'd love to see an example.
That was back in my slides. You may have missed it. Data quality rules are essentially defined as SQL statements, and they execute with a cursor. So when the data quality rule executes, I grab the identifier for that record and I store it into a rule violation table.
So you have like a separate ETL process type of thing?
Yeah, that was in my earlier slides, if you want me to
Okay.
go to back up.
Well, he said he'll review, so this is being
Okay.
recorded. So definitely, Peter, check out for your email for when this is going to be posted. Are there any other questions? I don't see anything so far, but wanted to make sure we have it open for anybody to ask. We'll give you just a few moments. It really has been a great session. I know that ETL work and healthcare, there are so many rules in healthcare, and you've done a great job of letting people see under the covers kind of thing.
Yeah, I wanted to basically try and get it as technical and show you the underlying structure as I could. It's amazing how simple this actually is. Like by using that data warehouse sequence ID as a unique identifier across all our tables, the whole table part of your data quality is no longer part of the equation. You don't have to worry about what table it occurred in, what the primary key of it was. All of that is gone. All you have to track is the data warehouse sequence ID. And that's unique across all our tables. So that flows to the fact table and that'll join to the errors.
Awesome.
Now, mind you, your data quality rules are going to take man years to develop.
Yes.
There's nothing you can do to avoid that, but the engine you can put in place in a day or two.
Wonderful. All right, so we'll go ahead and close out. We'll give you guys a few more minutes. Make sure you're stay tuned for our next session. Our next session is actually on 3 reasons to pick a time series platform for monitoring DevOps-driven microservices applications. And the speaker is going to be, I'm going to say his name completely wrong, Nadeep Sidhu. So hopefully I said that not totally wrong, but make sure you're definitely checking that out. Also, make sure you guys know that you will have a poll or a survey coming out after this to give a little bit of feedback on presentations. We had some great comments on how this is a great session, so make sure you guys are putting that out there. And thank you very, very much, everyone, for attending. Have a great day.